Jai Hind to all. My name is Divya Sharma. Now today's video lecture is on electric potential, electric dipole, energy density in electrostatic fields. So electric potential, it was covered in the previous lecture. So I will continue this electric potential with this slide. If the point charge Q is not located at the origin but a point whose position vector is r dash. So the potential V with coordinates x, y, z, or you can say VR at r becomes VR is equal to Q upon 4 pi epsilon naught. Q upon 4 pi epsilon naught in magnitude r minus r dash. As we have done with this r dash, then you can subtract this r dash from the original r. Now if you are considering end point charges, means q1 to qn, points located at points with potential vectors r1 r2 up to rn. So potential at r is equal to what? Vr is equal to q1 upon 4 pi epsilon naught in magnitude r minus r1 plus q2 upon 4 pi epsilon naught r minus r2 up to n, right down here. Now this is the final equation for when you have point charges q1 to qn. Now Vr is equal to 1 upon 4 pi epsilon naught summation k is equal to 1 to n. If you are considering there are a number of charges are present here, so write down here k is equal to 1 to n q k upon magnitude r minus rk. So this is the potential for point charges. Now find out the potential for line charge. So line charge, write down the value of qk. K is equal to what? Charge density into r, charge density into dl. So Vr is equal to 1 upon 4 pi epsilon naught integration for line charge. Write down here qk is equal to what? Rho L dl. So rho L in with respect to r dash, means you are finding here for this r becomes this point potential position vector is r dash. So find out for this line charge. So rho L r dash dl dash upon r minus r dash. Now Vr for surface charge 1 upon 4 pi epsilon naught integration rho S. If you are finding for surface charge, so take it here charge density for surface rho S in bracket r dash and ds dash upon magnitude r minus r dash. Now if you want to find out the for volume charge, so potential for volume charge is equal to 1 upon 4 pi epsilon naught integration rho v, this is charge density for volume, and in dot dv upon in magnitude r minus r dash. So these are the potentials for point charges, line charge, surface charge and volume charge. Now this is an example when you have 2 point charges, one point charge with minus 4 microcoulomb charge and second point charge is for 5 microcoulomb charge. Now these are located at this coordinate respectively. This is coordinate 2 comma minus 1 comma 3 and second coordinate is 0 4 minus 2. So here your first point charge is located at this coordinate and second point charge is located at this point. Now find out the potential at this point assuming zero potential at infinity. So as you all know q1 and q2 values, and write down the formula Vr is equal to q1 upon for this first charge, for the second charge plus C0. Now C0 here is 0, when if potential V infinity is equal to 0, then C0 is equal to 0. So find out here R minus R1 magnitude, find out. Now for R your point coordinates are 1 0 1, and for first point charge it means you are considering here R1 for this and R2 for this. So put here the coordinates of R1 2 minus 1 3 and find out the result that it be, that is under root 1 minus 2 ka square, 0 minus 1 ka square, 1 minus 3 ka square. So you will get here under root 6. Now for the second point charge r minus r2, so r coordinates are, as you all know, it is given here where you are considering we have to find out the potential at this point. So 1 0 1 and q2 charge is located at this point. So write down the coordinates of q2 charge. So 0 4 minus 2. Find out r minus r2 का magnitude, that is equal to under root 26. So put all these values here in this equation and find out V potential at this point 101. So put these values. This is minus 10 की power minus 6 upon 4 pi. So here this value Q1 and Q2 are in microcoulomb. So write down here microcoulomb, you can take common, 10 की power minus 6. Here you can write down Q1, then Q2 upon magnitude of R1, R2, and write down here the value of 4 pi epsilon naught. So this is the value of epsilon naught and 4 pi. So put all these values and you will get the potential at point 101, and your value for potential is minus 5.872 kilowatt. Now relation between electric field E and V, Maxwell equation. Now you have to find out the relation in between E and V. As you all know, you can see here, this is the electric field and you have 2 points A and B are representing here. Now here you have to find out the relation in between E and V. Now VBA is equal to minus VAB, and you all know VB, if you want to find out for the closed surface, then VBA plus VAB is equal to closed integration E dot dl is equal to 0. So here closed integral E dot dl is equal to 0, and now here put the value of that is E closed integral E dot dl is equal to what? Del cross E dot ds, that is equal to 0. Now here from this equation you will get here del cross E is equal to 0. So here you all know V is equal to what? Minus integration E dot dl. Now you all know dV is equal to, if you want to differentiate this potential, dV is equal to minus E dot dl. So here you can multiply this E dot dl as you are, if you are talking about the coordinate of x, y, z, means Cartesian coordinates. So your dl is in form of x, y and z. So put here, means you can multiply minus E to dl. So Ex dx minus Ey dy minus Ez dz. So you will get here dV, this is the differential potential, and dV is equal, as you all know, dV is equal to what? Del V upon del x dx plus del V upon del y dy plus del V upon del z dz. So this is also the equation, as already we have covered in the previous lectures. So we can compare this equation to this equation. So you can compare, so minus dx minus Ex and del V upon del x. So you will get here Ex is equal to minus del V upon del x, Ey is equal to minus del V upon del y, Ez is equal to minus del V upon del z. So when we are comparing these two equations, so we will get here Ex, Ey, Ez. Now here according to this is for coordinate x, this is for coordinate y, and this is for coordinate z. Now generally if you want to generalize this equation, then E is equal to minus del V. So this is the final equation, and or you can say this is the relation in between electric field intensity and this potential, electric potential. So let us consider an example. Given the potential V is equal to 10 upon r square sine theta cos phi, and find out the flux density, that is representing by D, at coordinate 2 minus 2 pi by 2, and the third is 0, and calculate work done in moving a charge is 10 microcoulomb from point A to B, and A's coordinates are 1 30 degree, 120 degree, and B's coordinates are 4 90 degree and 60 degree. So first you should know, find out the electric flux density. So electric flux density is equal to what? D is equal to epsilon naught E. Now here, as already we have done, a relation in between E and V is equal to what? E is equal to minus del V. Now here, put here, you have to write down here del V is equal to minus, you can take common from this bracket. Now del V upon del R. So write down coordinates in form of sphere, r theta phi, because you can judge it by this point A and B. It is in form of distance and this is in form of angle. So write down, these are coordinates are in spherical coordinates, so r theta phi. So write down here del v in form of r theta phi. So that is equal to minus del v upon del r unit vector of r plus 1 upon r del v upon del theta unit vector of theta plus 1 upon sin theta del v upon del phi unit vector of phi. So put here the value of, here you can put all these values. V is equal to 10 upon r square sin theta cos phi. So put all these values here. So you can put all these values, mean unit vector of r you can put here. You can put the value of del v upon del r, means you can differentiate it, this v with respect to r. Then after that we can differentiate the v with respect to theta. Then v differentiate with respect to phi. So you can differentiate it and you will get this result. Now after getting this result, then you have to put all these values. Now this E is equal to what? 20 upon r cube sin theta cos phi unit vector of r minus 10 upon r cube cos theta cos phi unit vector of theta plus 10 upon r cube sin phi unit vector of phi. So it is given in the question that you have to use this coordinate 2 comma pi by 2 0. So d is equal to epsilon naught E, right? So already we have done in the previous slide that d is equal to what? Sorry, E is equal to what? E is equal to this equation. So put here d is equal to epsilon E. So put this E here in this equation. So epsilon naught, when you are putting the value of r is equal to 2, theta is equal to pi by 2 and phi is equal to 0. So you will get this result 20 upon 8 unit vector of r minus 0 unit vector of theta plus 0 unit vector of phi. So here you can put the value of epsilon naught and you will get the value d is equal to 22.1. As v is known here, so if you want to find out the work done, so second part is work done, as we have done in the previous slide, that work done is equal to what? Minus q limit integration a to b e dot dl. So this is equal to what? Q VAB, means this is potential a to b. So v is AB is equal to integration a to b e dot dl. So put here VAB, and if you want to find out VAB, so VAB is equal to what? VAB is equal to VB minus VA, and you all know the value V potential is given in question, and put here the value 10 upon 16 sin 90 degree, means you have to put your V is equal to what? V is equal to 10 upon r square sin theta cos phi. So put the value here A for A and B. So first write down VB minus VA. So when you are writing this, when you are finding VAB, so put here the value of 4 comma 90 degree comma 60 degree and put here values 1 comma 30 degree comma 120 degree. Then you will get VB and VA, and your V is given 10 upon r square sin theta cos phi. So put all these values of A and B and you will get VAB. So VAB is equal to what? While you are putting the value for A and B, you will get here 10 in bracket 10 upon 16 sin 90 degree cos 60 degree minus 10 upon 1 sin 30 degree cos 120 degree, and this is microcoulomb charge. So that is 10 की power minus 6. So you will get here 10 by 32 minus 5 by 2, 10 की power minus 6. So this is the obtained results, means work done. Work done is equal to 28.125 microjoule. So while you are putting all these values, you will get this result for work done. Now next topic is an electric dipole and flux lines. Now let it be you have a coordinate x, y, z, you have a point P and there is an origin. So when you are focusing from this point on this z axis, so this is your point 1 and 2. So first point is charge on this point is plus q and charge on this point is minus q, and distance between these 2 points is representing by d. And when you are joining this point to origin, so angle between this z axis to this origin distance, that is equal to theta. and when you are focusing from this point to this z axis, so this is r1, this is r2, and when you are joining the origin, that is distance is r. Now here from this point to this point your distance is d cos theta. Now here potential you all know V is equal to what? Q upon 4 pi epsilon naught in bracket R1 upon R1 minus 1 upon R2. Now here you can take LCM and you can find out that is equal to what? Q upon 4 pi epsilon naught R2 minus R1 upon R1 into R2. So here if R is greater than D, greater than D, then R2 minus R1 is equal to D cos theta and R2 R1 is equal to R square. So put this value in this equation. So R2 minus R1 is equal to what? D cos theta, and R1 into R2 is equal to R square. So put all these values here in this equation and you will get here V is equal to Q D cos theta upon 4 pi epsilon naught upon R square. Now here D cos theta is equal to what? D dot unit vector of R, and D is equal to, where D is equal to D unit vector of Z, and we have done earlier that P is equal to QD. So put this value P is equal to QD, means QD is there in the previous equation, that equal to QD cos theta 4 pi epsilon naught R square. So put the value of QD here, that is equal to what? That is P. So write down here your potential is here V is equal to P unit vector of R upon 4 pi epsilon naught R square. Now dipole, this is represents dipole moment. Is representing by P. So it is from minus Q to Q, and if the dipole center is not at the origin but at R dash, there is a point R dash in the figure, then you have to write down here for R, VR is equal to, means you have to write down the unit vector R, that is in form of AR is equal to R minus R dash upon magnitude R minus R dash. So this is the unit vector of R. Here put this value here in this equation and you will get V in bracket R is equal to P dot R minus R dash upon 4 pi epsilon naught R minus R dash का magnitude का Q. Now here write down the relation in between E and V. E is equal to minus del V. So put here del V. So del V R for the unit vector of R and theta, that is equal to minus del V upon del R unit vector of R plus 1 upon R del V upon del theta unit vector of theta. So put here the value of dV upon del R, del V upon del R. So that is equal to QD cos theta upon 2 pi epsilon R cube unit vector of R. Now here also put the value of dV upon del theta. So Q d sin theta upon 4 pi epsilon naught R cube unit vector of theta. So finally you will get this equation E is equal to, well you are putting the value of QD, that is equal to P. So E is equal to P 4 pi epsilon naught R cube 2 cos theta unit vector of R plus sin theta unit vector of theta. So this is the final equation when you will put the value of dipole QD is equal to P. Dipole moment, so that is QD is equal to P. So put this value and you will get this electric field. Now electric flux lines. Electric flux lines is an imaginary line or the line drawn in such a way that its direction at any point is the direction of the electric field at that point. So first you are taking the case of equipotential surface for point charge, and this is the equipotential surface for electric dipole. Now here consider a charge with positive sign and these are your flux lines and this is your equipotential surface. Now if you are considering the case of electric dipole, so electric dipole means there is some charge here and here, and your electric potential surface, this is your electric potential surface, and you have both charges in opposite direction. So your direction is in the for this charge is in this direction, and for this space you have charge in the opposite direction. So this is the case when V is greater than equal to 0, This is the second case when V is less than 0. And these are your flux lines. Now, next topic is energy density in electrostatic fields. Now here let us consider you have P1, P2, P3 points are on this surface, and let us consider a point is at the infinity. So charge Q1 is the charge when you are considering the case when you have a point at infinity to P1, then your charge is Q1. If you are second case Q2 and the third case is Q3. Now here energy density in electrostatic field, you have to find out work done, means energy density for in electrostatic field, that is represented by WE. So here charges are Q1, Q2, Q3. So find out for W1, W2 and W3. So put the value here W1, W2, W3 here, that is in form of QV, as we have done earlier, that how to find out energy work done for the field. So W1 is here 0, W2 is Q2, V2 1. If you are considering W2, means you are taking your charges were positioned in the reverse order also. First you are going from this place to this place, this point, but then you are taking in reversed order. First you are going from this point to the infinity point. So work done W1 is equal to 0, W2 is equal to Q2, V2 1, W3 is equal to Q3, V in bracket V3 1 plus V3 2. Now here if the charges were positioned in reverse order, then you have to take W3 first, then W2, then W1. So WE you can find out in the reverse order, that is 0, Q2, V2 3 plus Q1, V1 2 plus V1 2. Now find out if you are adding this equation and this equation, then you will get here 2WE. So you have to add these values and you will get here Q1 V1, Q2 V2, Q3 V3. Why you are writing here? V1 is equal to what? V12 plus V13, means your potential is from point 1 to 2, then 1 to 3. So that is your source is V1. Now when you are considering V21 plus V23, then your source is V2. So write down here V2. Now V31 plus V32, that is equal to what? That is equal to V3. So finally 2WE is equal to Q1 V1 plus Q2 V2 plus Q3 V3. And find out here WE is equal to what? W is equal to 1 by 2 Q1 V1 plus Q2 V2 plus Q3 V3. Here, so where V1, V2, V3 are total potentials at point P1, P2, P3 respectively. Now, if you have n number of charges, so write down equation for n number of charges, that is equal to what? This is the energy potential for the this field. W is equal to 1 by 2 summation K is equal to 1 to n Q K V K, if you are considering n number of charges, or you can say n number of points are there and you have to find out potential for all that points. Now here the region, if instead of point charges the region has a continuous charge distribution, means this is for point charge. If you have line charge, if you have surface charge, if you have volume charge. So how you can write down this equation? W is equal to 1 by 2 rho L VDL, this is for line charge, and W is equal to 1 by 2 integration rho S VDS for surface charge, and the third one WE is equal to 1 by 2 integration rho V dV is for the volume charge. Now generally you have to write down this equation, W is equal to 1 by 2 del dot d V dV. Now here, but for any vector A and scalar V, the identity is equal to what? As you all know the formula, del dot VA is equal to what? A dot del V plus V in bracket del dot A, means you have to take the divergence here for V and then for A. Now here del dot A, if you want to find out del dot A V is equal to what? Del dot del V minus A del dot del A dot del V. So you can find out for this. How you can find out? This is equal to what? This minus this. So write down here. So you can put here del dot dV is equal to what? You can find out. Let us consider this is D. Del dot dV. So write down this equation for W. Put all these values in. W is equal to what? W is equal to 1 upon 2 integration del dot V dV V d dV minus 1 by 2 integration d dot del v dv. So put this value here in this equation. Now while you are applying divergence theorem, the first term on the right hand side of this equation we have w is equal to 1 by 2 closed integral. Now here you are taking closed integral, means first you are going from one point to another point, then you are taking the reverse direction. So that is equal to what? W is equal to 1 by 2 closed integration v d dot ds minus 1 by 2 integration d dot del v dv. Now here when you are taking a closed integral, then w is equal to what? Minus 1 by 2 integration d dot del v dv is equal to 1 by 2 integration d dot e dv. dv. Now here put the values, as you all know, E is equal to minus del v and d is equal to epsilon naught E. So put these values and you will get here d dot E. As you can put the value of del v is equal to E, so put here E. So you will get here w is equal to 1 by 2 d dot e dv. Now here put the value of d. So d here is what? D is equal to epsilon E. So put here the value of d, then you will get here 1 by 2 epsilon naught E square dv. Now here you have to find out the differential of WE. So differential of WE, you have to take differentiation of this. So you will get here 1 upon 2 dE. Now here when you are putting the value of d, then you will get 1 by 2 epsilon naught electric field ka square, that is equal to what? D square upon 2 epsilon naught. It means W is equal to what? W is equal to D square 2 epsilon naught. So this is the final value. Now let us consider an example. You have 3 point charges. First point charge is minus 1 nanocoulomb, second is 4 nanocoulomb, third is 3 nanocoulomb, are located at this point 0, 0, 0, 0, 0, 1 and 1, 0, 0. Now find out the energy in this system. As you all know, W is equal to what? W1, W2, W3 when you are considering 3 point charges. So W1 is equal to 0, W2 is equal to Q2 V21, means let us consider you are considering this point 1, this is point 2, this is point 3. So at this point 1 you have 0. So from this point to this point, write down here V21. When you are considering the third one, V31 plus V32. So put all these values which are given in your question 0, 0, 0, 0, 1 and 0, 0. So first you have to write down for this combination, that is equal to what? Q2 Q1 4 pi epsilon naught 0, 0, 1 minus 0, 0, 0. Now considering the case for Q3, so 4 pi epsilon naught, so put here the value of V31, V32. So Q1 upon 1, 0, 0 minus 0, 0, 1. Now plus Q2 upon 1, 0, 0 minus 0, 0, 1. So find out the value for all these charges, then you will get here 1 upon 4 pi epsilon naught Q1 Q2 plus Q1 Q3 for second one and the third one for Q2 Q3. When you are multiplying this to this, then Q2 Q3 upon under root 2. Now here put the value of 1 upon 4 pi epsilon naught. So 4 pi is there, put the value of epsilon, that is equal to 10 to the power minus 9 upon 36 pi, and put here the value of, as you have charges are in nanocoulomb, so put here 10 to the power minus 9, and then you will get the, when you will put all these values, then you will get the result, that is equal to W is equal to 13.37 nanojoule. Thank you.